Data analytics, so optimization with Excel Solver. Introduction. Solver is a Microsoft Excel add-in program you can use for optimization in what-if analysis. According to O'Brien and Maracas, optimization analysis is a more complex extension of goal-seeking analysis. Instead of setting a specific target value for a variable, the goal is to find the optimum value for one or more target variables under certain constraints. Then one or more other variables are changed repeatedly, subject to the specified constraints, until you discover the best values for the target variables. In Excel, you can use Solver to find an optimal value, the maximum or minimum, or a certain value, for a formula in one cell called the objective cell, subject to certain constraints or limits on the values of other formula cells on the worksheet. This means that the solver works with a group of cells called decision variables that are used in computing the formulas in the objective and constraint cells. Solver adjusts the values in the decision variable cells to satisfy the limits on constraint cells and produce the result you want for the objective cell. You can use Solver to find optimal solutions for diverse problems such as determining the monthly product mix for a drug manufacturing unit that maximizes the profitability, scheduling workforce in an organization, solving transportation problems, financial planning, and budgeting. Activating the Solver add-in. Before you proceed with finding solutions for a problem with Solver, ensure that the Solver add-in is activated in Excel as follows. Click the Data tab on the ribbon, then the Solver command should appear in the analysis group as shown below. So we have here the Solver. So click on the data, then we have here the Solver in the analysis group. So in case you do not find the Solver command, activate it as follows. So click on the File tab and click Options in the left pane. Excel Options dialog box appears. Click Add-ins. So Add-ins in the left pane, then select the Excel add-ins in the Manage, and then be sure this Excel add-ins, and then you click Go. The add-ins dialog box appears, and check Solver add-in and click OK. Now you should be able to find the Solver command on the ribbon under the Data tab. Solving methods used by Solver. You can choose one of the following three solving methods that Excel Solver supports based on the type of problem. So we have LP Simplex. So these are used for linear problems. A solver model is linear under the following conditions. The target cell is computed by adding together the terms of the changing cell times the constant form. Each constraint satisfies the linear model requirement. This means that each constraint is evaluated by adding together the terms of the changing cell times constant form and comparing the sums to a constant. Generalized reduced gradient, so GRG, nonlinear, used for smooth nonlinear problems. If a target cell, any of your constraints, or both contain references to changing cells that are not of the changing cell times constant form, you have a nonlinear model. Then we also have the evolutionary, used for smooth nonlinear problems. If a target cell, any of your constraints, or both contains references to changing cells that are not the changing cell times constant form, you have a nonlinear model. Understanding solver equations. The solver requires the following parameters. We have decision variable cells, constraint cells, objective cells, and the solving method. Solver evaluation is based on the following. the values in the decision variable cells are restricted by the values in the constraint cells. So we have decision variable cells and constraint cells. The calculation of the value in the objective cell includes the values in the decision variable cells. Solver used the chosen solving method to result in the optimal value in the objective cell. So defining a problem. Suppose you are analyzing the profits made by a company that manufactures and sells a certain product. You are asked to find the amount that can be spent on advertising in the next 2 quarters, subject to a maximum of 20,000. The level of advertising in each quarter affects the following. So the number of units sold, indirectly determining the amount of sales revenue, the associated expenses, and the profit. You can proceed to define the problem as, so we have the find unit cost, find advertising cost per unit, and find the unit price. So in that case, we have this one. So we have the unit cost, unit price, and advertising cost per unit. Next, set the cells for the required calculation as given below. So as you can observe, the calculations are done for quarter 1 and quarter 2 that are in quarter 1 and quarter 2 that are in consideration are the number of units available. So these are the number of units available. So for quarter 1 it is 400 and for quarter 2 is 600. So they're in cells C7 and D7. The initial values for advertising budget are set as 10,000 per quarter. So they are placed at cell C8 and D8. The number of units sold is dependent on the advertising cost per unit and hence is budget for the quarter advertising cost. So hence budget for the quarter divided by advertising cost per unit. Note that we have used the minimum function to take care to see that the number of units sold in is less or equal to the number of units available. This is our cells C9 and D9. So here, the number of units sold should be equivalent to C8, the budget, divided by the cost. So since this is it's only the number of units we can sell, or whichever is lesser, this or 400, because that's the maximum value that that's only the units available. So if this is higher than this, we should follow this. But if this is lesser than 400, then we should follow C8 divided by C4. So the same is true with the second quarter. Revenue is calculated as, so unit price. So we have the unit price, that's C3 times the number of units sold, which is C9. Okay, so both in cells C10 and D10, but for D10 instead of C9 we use D9, but both will be using this price. Expenses is calculated as the unit cost times the number of units available, so that's C2 times C7 plus advertising cost. So plus the advertising cost, which is actually placed at C8, the maximum. Okay, the expenses will be cost per unit times the number of maximum units plus the budget. Profit is revenue minus expenses. So we have revenue, which is at cell C10 minus C11. So C10 minus C11. Here the same, we have D10 minus D11. And the total profit is profit in quarter 1 plus profit in quarter 2. So we have placed here the total profit. So we have C1 plus D12. So we have now set up our calculations. Next, you can set the parameters for solver as given below. So these are the parameters for the solver. So we have the total advance or advertising budget is equal to C8 plus D8. And then we have here the number of units sold in quarter 1, which is actually C9, and the number of units sold in quarter 2, which is D9. And later on, I'll explain this because it has something to do with the constraints. As you can observe, the parameters for solver are the objective cell is D3 that contains total profit which you want to maximize. So D3 is the total advertising budget. That is what we set to maximize. Contains a total profit. D3 rather. Sorry. So this is a total profit. This is what we want to maximize. Decision variable cells are C8 and D8. So these are the decision variable cells. So we would like to know what will be the optimal budget for the first quarter and the second quarter. So quarter 1 and quarter 2. And the three constraint cells are C14, C15, and C16. So C14, this one. So the total budget should only be equal to the 2. And so it's a total budget. So the constraint is 20,000. Cell C15 that contains the number of units sold in quarter 1 is set to the constraint lesser or equal to the number of units available in quarter 1. That's why C9, which is the total number of units, should not be higher than this one, what is placed at cell C7. And the same for the second quarter. So the number of units sold should not be higher than the number of units available for the second quarter. So that will be at cell C15 and C16. That's why we place here the units, total units available. And this is the total budget available. So these are the constraints. Okay, so these are the constraints. Solving the problem. The next step is to use solver to find the solution as follows. Step 1, go to data analysis, data and then analysis, then solver on the ribbon. The solver parameters dialog box appears. So this is the solver parameter dialog box. Then step 2, in the set objective box, so set objective box, select the cell D3. So the cell D3 is the cell that's our objective. We would like to know the total profit, the maximum profit that we can have by adjusting the variable. So later on, let's go back to the variable. Then select max. So we would like to know the maximum. Then step 4, select range C8 to D8 in the by changing variable cells. So again, we would like to know if we change this value, what will be our maximum profit. So given these parameters or conditions here. So we would like to know what will be the values here. That's why here we have to specify by changing the variables, so C8 to D8. So these are the changing variable. Then step 5, click the add button to add 3 constraints that you have identified. So we have 3 constraints here. So these are the constraints. So we click add. So the add constraint dialog box appears. Set the constraint for total budget as given below and click Add. So for cell C14, it should be lesser or equal to D14. So let's go back. For cell C14, the total advertising budget should be lesser or equal to 20,000. So it should not exceed 20,000 because that's the only allocated budget for advertising. And then in step 7, the constraint for total units sold for quarter 1. So C15 is lesser or equal to D15. So what's that? So that's the total number of units sold for quarter 1 with this one, C15. It should not exceed C7 or 400. Should not exceed 400, which is the number of units available for quarter 1. And without looking at the next step, but the next step will be defining this constraint. So for D9, or the number of units sold for quarter 2 should not exceed D7 or 600. So this one is for the first quarter and this one is for the second quarter. So set the constraint for total number of units sold in quarter 2 as given below and click OK. So C6 is lesser or equal to D16. Then the solver parameter dialog box appears with the 3 constraints added in box, subject to the constraints. So in the select a solving method, select simplex LP, so linear programming. Click the solve button. So we have here the solve button. Click the solve button and the solver results dialog box appear. So this is a solver result dialog box. Select keep solver solution and click OK. The result will appear in your worksheet. So this is now the result. As you can observe, the optimal solution that produces maximum profit, so this will be our total profit, subject to the given constraints, is found to be the following. So the total profit will be 30,000 and the advertising budget for quarter 1 should be 8,000 and the advertising budget for quarter 2 should be 12,000. So that's a solution. Now we can also step through the solver trial solutions. So you can see the many values that are tried by Excel. So you can step through the solver trial solutions by looking at the iteration results. So click the options button in the solver parameters dialog box. So there's that button, the options dialog box appears. So we have the option dialog box. Select the show iteration results box and click OK. Then the solver parameters dialog box appears. Click solve. So we click solve and then the show trial solution dialog box appears. So this is the trial solution dialog box displaying the message solver post current solution values displayed on worksheet. So this is now the current solution. So if we have 8,000 for quarter 1 and no budget for quarter 2, the profit is negative 18,000. So as you can observe, the iteration values are displayed in your working cells. You can either stop the solver accepting the current result. If you want this result, you can accept that. So by clicking stop, or continue with the solver from finding solutions in further steps. So let's continue. We click continue, the continue button, and the show trial solution dialog box appears at every step. So this will be updated and you can always click continue. So solver results dialog box appears. Your worksheet is updated at every step, finally showing the result values. So the values here will be changing and you will see the value of profit. You have the following saving options for the problems that you solve with solver. You can save the last selections in the solve parameters dialog box. with a worksheet by saving the workbook. Each worksheet in a workbook can have its own solver selections, and all of them will be saved when you save the workbook. You can also define more than one problem in a worksheet, each with its own solver selection. In such a case, you can load and save problems individually with the load or save in the solver parameter dialog box. Click the load save button and the load save dialog box appears. To save the problem model, enter the reference for the first cell of the vertical range of empty cells in which you want to place the problem model. Then you click save. So in this case, he clicked F2. That's why we have to click F2. Then click save. So the problem model, the solver parameter set, appears starting at the cell that you have given us the reference. So these are the values that appears on these. To load the problem model, enter the reference for the entire range of cells that contains problem model, then click on load button. So click on this and then click on the load button. Okay, so that ends our lecture for this topic, which is about Excel solver. Okay, so thank you very much for viewing this video.